Okay, so we're starting our chemistry unit this year with a little bit of a demonstration where we're actually taking a look at the components of water. And what we call this the electrolysis of water because it involves using electricity to break water down into its components. Now you probably know about water being made of hydrogen and oxygen. You've probably heard of H2O before. So but what exactly, how does this all work? How does this all come together? How does it get taken apart? That's what we're going to take a look at here. So we have this setup which looks something like this. We have a power supply where we have a negative charged electrode. Let me follow it along here, right there. And then we have a positive charged electrode coming from a power supply right there. And what I'm going to do now is I'm going to show you the actual setup. But this is the diagram, and it shows gases being attracted to the negative electrode as well as gases being attracted to the positive electrode. Anyway, that's the setup, and here's what we have over here. You can see what's going on. So there's our power supply in the back, the yellow wire there, which then turns into the black wire, is the negative charged electrode, which is giving off bubbles. You can see it right here inside the beaker, inside this water. Now this water has magnesium sulfate dissolved in it to help conduct electricity. But we can see all the bubbles coming off of that negative electrode. And they're being collected up in this tube, which was at one point filled with water. Now as the gas collects, it drives the water out of the test tube. Over here is the positive electrode, the positive wire coming from the power supply. It is also, here we go, that's a better shot. It's also collecting gas on this electrode as well. So these are the observations that we see. We see gases being collected on the positive electrode. We see gas being collected on the negative electrode as well. But is there any difference? Well, if you take a look up here in the positive tube, and they started at exactly the same time, we've gotten this much gas collected in that test tube. Take a look over this test tube over here. Let me see if I can get a different shot at it. And you can see in here that there's a lot more gas collected in this one than there was in the positive electrode. Maybe like twice as much gas. Interesting. And we know that water is H2O. So the idea is that we're trying to figure out what these gases are. Well, they could be a lot of different things. But we know that water is made of hydrogen and oxygen gas. And we know that water is made of, we've heard of H2O before, whatever that means. Maybe it means 2 parts hydrogen, 1 part oxygen. So it stands to reason that in the negative electrode, we might have the gas hydrogen being collected. And in the positive electrode, maybe the gas oxygen is being collected. Perhaps. But we have to prove it. We have to test it. The other thing is this. We know that there are 2 different gases being collected on these electrodes. Now the reason we know that is because they're behaving differently. One gas is being attracted to the positive charged electrode. Another gas is being attracted to the negative charged electrode. So we can infer that these are 2 different gases because they're behaving differently with different electrode charges. So I'm going to stop the video now and come back to it, and we'll take a look at, when we collect enough gas in the test tubes, we'll take a look at what these gases are, and we'll attempt to do some tests on them to find out exactly what gas we're dealing with. Okay, so now we have collected enough gas in our test tubes so we can do some tests on them. Now we suspected in the positive tube that this might be oxygen. The reason we thought that was because, well, we think about water being made of hydrogen and oxygen gas, H2O, and felt like there was twice as much gas in the negative, with the negative electrode in the negative tube as there was in the oxygen. So, and it did take about twice as long to fill up the oxygen test tube, the one we suspect is oxygen. So I'm going to test that one first. Now, what do we do for that? Well, oxygen, the test that works best for oxygen is to see if it can support a flame, to see if it can support combustion. It's the only gas that can. Any other gas would put a flame out. So if I were to put a small flame up into the oxygen test tube, or a glowing stick, a hot glowing stick, what would happen? Would it glow brighter? Would this flame get bigger in pure oxygen? So let's find out what happens in the test tube marked with the positive sign, the gas that came off the positive electrode, and see if it in fact has the properties of oxygen. Okay, let's see what happens when I put this stick inside the test tube. It contains oxygen. Well, look at that. Look how it's glowing brighter, all right? So I've had this hot glowing stick that I lit on fire, I just blew it out, and look what happened. When I put it into the tube that we suspected contained oxygen, it glowed a little bit brighter. So that would indicate that, you know, we've got some oxygen in here, and it helped to increase the combustion that was taking place on that stick. Okay, so this is the tube that we suspected may have had hydrogen gas in it, as the other one, it contained oxygen. We know that water is made of hydrogen and oxygen, so let's see what happens when we put a flame to the hydrogen gas. Whoa, did you see that? All right, did you hear that? And what we had there was a little pop, a little bit of an explosion, and we had that whistling noise. Something else that happened here as well. The test tube fogged up. You know, we had a little oxygen in there, and with the flame, with the hydrogen gas inside this test tube, we combined the oxygen from the air along with the hydrogen that was in here, and we formed water, and it collected on the side of the test tube. So that's pretty cool. So we actually made water from the hydrogen gas that was in this tube. So we've got evidence to support that the tube that was over the negative electrode was collecting hydrogen gas, and because it caused the hot glowing stick to glow even brighter, all right, we have proof that there was oxygen or pure oxygen in this particular tube. If we just kept it out in the air, it wouldn't have glown, really would not have glowed brighter like that. So we have evidence to support that we actually took oxygen from the water as well as hydrogen gas from the water and broke it down into its components, which are oxygen and hydrogen are both elements.